The night of December 11th, 1942, Iron Bottom Sound, off the north coast of Guadalcanal, Lieutenant Lester Gamble throttled PT-37 forward through the darkness, his boat's 3 Packard engines pushing the 80-foot wooden hull through waters so black they seemed to swallow starlight. Behind him, 4 more PT boats spread across the sound in a patrol line, their crews scanning the horizon for shapes that shouldn't exist. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Somewhere out there, 11 Japanese destroyers were racing south at over 30 knots, carrying troops and supplies for the beleaguered garrison on Guadalcanal. The Americans called it the Tokyo Express, the Japanese called it the Rat Run. Both sides knew that tonight's convoy could change the balance of the entire Guadalcanal campaign. Gamble checked his watch. 01:30 hours. Intelligence said the Japanese destroyers would arrive around 0200. His boat carried 4 Mark 8 torpedoes, each weighing 2,600 pounds with a 466-pound warhead. Theoretical range, 16,000 yards. Actual effectiveness, much debated. The torpedoes were temperamental, prone to running deep, running shallow, or simply not exploding when they hit. But tonight, temperamental torpedoes were all that stood between 11 enemy destroyers and Guadalcanal. The wooden boat beneath Gamble's feet measured 80 feet long, displaced 56 tons, and was powered by 3 12-cylinder gasoline engines generating 4,500 horsepower. Maximum designed speed, 41 knots. This small fact, this promise of speed written into blueprints back in Bayonne, New Jersey, was about to collide with Japanese assumptions about naval warfare in a way that would echo through the Pacific War. The Japanese Navy had spent the past decade building what many naval historians considered the finest destroyer force in the world. Ships like the Fubuki class displaced over 2,000 tons, mounted 6 5-inch guns in enclosed turrets, and carried the Type 93 torpedo, the oxygen-fueled long lance that could race 24,000 yards at 49 knots. These destroyers were designed for night fighting. Their crews trained endlessly for it. They had optical equipment superior to anything the Americans fielded, and tactics refined through years of doctrine development. When Japanese destroyer officers looked at their potential opponents in the South Pacific, they saw American destroyers that were formidable, American cruisers that were dangerous, and American battleships that demanded respect. They did not see 80-foot plywood boats as credible threats. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The PT Boat Patrol torpedo boat was an American attempt to build a weapon that shouldn't work. Take 3 aircraft engines designed for bombers, marinize them, bolt them into a wooden hull constructed from 2 layers of 1-inch mahogany planking, load the result with torpedoes heavier than automobiles, add machine guns and a teenage crew, and send it to fight warships 10 times its size. On paper, it was absurd. In practice, it remained absurd, but occasionally effective. The development of PT boats reflected America's late entry into the motor torpedo boat concept. The British had been building motor torpedo boats since the 1920s. The Germans had E-boats. The Italians had MAS boats that had famously penetrated Polar Harbor during World War I. The Americans had interested theories and congressional debates. It wasn't until 1938 that the US Navy began serious development of patrol torpedo boats. The Navy issued specifications calling for wooden craft no longer than 82 feet, powered by 3 Packard engines with mufflers to mask their approach, capable of making 40 knots. The boats had to carry torpedoes, the standard 21-inch Mark 8, and enough machine guns to defend themselves. Range requirements meant carrying 3,000 gallons of 100-octane aviation fuel, enough for a maximum 12-hour patrol. The fuel consumption of the Packard 4M 2500 engines was phenomenal. At cruising speed of 23 knots, each engine consumed 66 gallons per hour. At top speed, consumption increased to 166 gallons per hour per engine. 500 gallons per hour, total, for all 3 engines running flat out. By 1941, the Navy had settled on 2 standard designs, a 78-foot Higgins boat, and an 80-foot Elco craft. Both types shared the same basic specifications: 3 Packard engines, 41-knot design speed, 4 torpedoes, machine guns, wooden construction using mahogany planking, plywood, and significant quantities of glue. No armor. The crews varied from 12 to 14 men, 3 officers, and 9 to 11 enlisted. They were, as one historian later wrote, floating bombs waiting for the right spark. The Packard 4 M2500 engines were remarkable pieces of engineering. Based on aircraft engine designs, they featured superchargers, intercoolers, dual magnetos, 2 spark plugs per cylinder, all the sophisticated technology of bomber engines, adapted for marine use. Initially generating 1,200 horsepower each, they were subsequently upgraded to 1,500 horsepower for a designed speed of 41 knots. Navy acceptance trials for every boat required it demonstrate the ability to achieve design speed of 41 plus knots. This wasn't mere paperwork. Every PT boat that left the factory had proven it could hit 41 knots on measured mile runs, but design speed and combat speed were different things. Fully loaded with torpedoes, ammunition, extra fuel, and combat gear, PT boats often operated below 30 knots in rough seas. Their wooden hulls, while surprisingly strong, pounded brutally in heavy weather. The planing hull design that gave them speed in calm water made them bucking broncos in anything resembling a real ocean. Crews got soaked, equipment got drenched, and the boats themselves required constant maintenance just to remain operational. The Japanese, watching American PT boat deployments in the Philippines in early 1942, were not impressed. Initial reports from destroyer captains who encountered PT boats in Philippine waters described them as nuisances at best. The boats were small, hard to see at night, and occasionally launched torpedoes that almost never hit. Japanese destroyer doctrine emphasized aggressive night action supported by searchlights, optical superiority, and overwhelming firepower. A properly illuminated PT boat made an excellent target for 5-inch guns. Several PT boats were, in fact, blown to splinters by Japanese destroyer fire in the Philippines. But something unexpected happened during those early encounters. The PT boats were fast. Not just fast for small boats, fast compared to destroyers. A standard Fubuki-class destroyer, after refit and ballasting to correct stability problems, could make 34 knots under ideal conditions. The Akizuki-class anti-aircraft destroyers, newer and more powerful, could make 33 knots. These were extremely fast ships by any standard, but they weren't faster than a PT boat running on all 3 engines. A PT boat at 41 knots wasn't just quick, it was untouchable by anything except another PT boat or aircraft. This speed differential created a tactical problem Japanese destroyer commanders had never seriously considered. What do you do when your target can outrun you? Traditional destroyer tactics assumed you could chase down smaller vessels, but PT boats didn't behave like traditional torpedo boats. They appeared from nowhere, launched torpedoes, and then simply outran any pursuit. Japanese searchlights could illuminate them. Japanese guns could shoot at them. But unless you hit them quickly before they accelerated to escape speed, they were gone into the darkness. The night of December 7th, 1942, exactly 1 year after Pearl Harbor, marked the first time PT boats seriously threatened a major Japanese destroyer operation. Rear Admiral Raizo Tanaka, commanding 11 destroyers carrying troops and supplies to Guadalcanal, knew PT boats were operating from Tulagi. Intelligence reports mentioned them, but Tanaka had more serious concerns. American cruisers and destroyers had been contesting the waters around Guadalcanal for months. Several major naval battles had turned Iron Bottom Sound into a graveyard for warships from both sides. The battleship Kirishima lay on the bottom, along with multiple cruisers and destroyers. PT boats, in Tanaka's operational calculus, rated somewhere below air attack and well below American surface forces as threats. At Naval Operating Base Tulagi, Lieutenant Commander Alan Montgomery reviewed intelligence reports and did the mathematics. 11 Japanese destroyers against his available PT boats. He had 15 boats operational that night. against over 30,000 tons of enemy warships mounting dozens of 5-inch guns, carrying hundreds of highly trained sailors, equipped with the world's best torpedoes and night-fighting doctrine honed through years of practice. Montgomery's plan was simple because it had to be. Spread the boats in patrol groups across the likely approach routes. Wait until the Japanese destroyers were close enough to hit. Launch torpedoes. Run like hell. The PT boat crews preparing for the night patrol understood the odds. Japanese destroyers could obliterate them with single hits. The 5-inch shells would punch through mahogany planking like it was paper. A direct hit to the fuel tanks meant instant cremation. 3,000 gallons of aviation fuel didn't burn. It exploded. But the crews also understood something else. They were the only American forces in position to intercept tonight's Tokyo Express. The Marines on Guadalcanal were depending on them. If Tanaka's destroyers delivered their cargo unopposed, Japanese forces on the island would be reinforced and resupplied. If the PT boats could disrupt the delivery, or better yet, sink some destroyers, it would give the Americans another night's advantage in the grinding campaign for Guadalcanal. Lieutenant Gamble, commanding PT-37, had participated in night patrols before. He'd seen Japanese destroyers in the distance, illuminated by muzzle flashes during surface actions with American cruisers. He'd fired torpedoes that vanished into darkness without visible result. The Mark 8 torpedo was a source of endless frustration. Too slow at 28 knots, it couldn't catch a fleeing destroyer. Its depth settings were unreliable, its magnetic detonator often malfunctioned, and even when everything worked perfectly, hitting a maneuvering destroyer at night from a bouncing PT boat required more luck than skill. But 41 knots of speed was reliable. The Packard engines, for all their fuel consumption and maintenance requirements, delivered power. The planing hull, for all its rough ride in heavy seas, achieved remarkable speeds. And speed was survivability. Speed meant you could close with enemy destroyers, launch your torpedoes from ranges they didn't expect, and disappear before their gunfire found you. Speed meant the difference between being a target and being a ghost. At 0200 hours, radar pickets reported contacts moving south through the slot, the channel between the Solomon Islands that Japanese forces used for their resupply runs. Multiple contacts, moving fast. Tanaka's destroyers were on schedule. Montgomery ordered all PT boats to their patrol stations. Gamble advanced throttles, feeling PT-37 surge forward as the 3 engines synchronized. Behind him, PT-40 and PT-48 matched his course. Further back, PT-44 and PT-110 moved into position. The trap was set. The Japanese destroyer force ploughed south at 30 knots, their crews at battle stations, optical equipment scanning for threats. Tanaka's flagship led the formation, the newly arrived Akizuki-class destroyer Teruzuki, mounting 8 10-centimeter dual-purpose guns in 4 turrets. She was one of the most modern destroyers in the Japanese fleet, designed specifically to protect carriers from air attack, but armed with torpedoes and perfectly capable of surface action. Displacing 2,700 tons standard and over 3,000 tons fully loaded, Teruzuki represented everything the Imperial Japanese Navy had learned about destroyer design. Her crew numbered 300. She was 440 feet long, and she was absolutely, completely confident in her superiority over anything smaller than a cruiser. The night was moonless, the sea relatively calm, perfect conditions for a resupply run. Tanaka maintained formation, his destroyers moving in line ahead at intervals that allowed maneuver but maintained concentration of force. Standard doctrine. They'd done this run dozens of times. American air power owned the daylight hours, but darkness belonged to the Japanese Navy. Then PT-37's radar operator called contact, bearing 320, range 4,000 yards, multiple targets, moving south. Gamble altered course to intercept, ordering his other boats to follow. The range closed rapidly, the destroyers doing 30 knots, the PT boats doing 40. 3 minutes later, lookouts spotted the dark shapes against the slightly lighter sky. Destroyers, many of them, moving in column formation. Gamble calculated angles, speeds, and distances. The Mark 8 torpedo required a nearly perpendicular approach for best chance of hitting, too acute an angle, and the torpedo might not arm properly. Too obtuse, and it would simply pass astern of the target. He needed to get close inside 2,000 yards, then turn to present his beam to the enemy while launching, which meant closing with Japanese destroyers until they could hardly miss hitting him with gunfire. The Japanese lookouts spotted PT-37's wake at roughly the same moment Gamble began his attack run. Teruzuki's 10-centimeter guns swung toward the contact, optical rangefinders calculating distance and deflection. But the PT boat was moving at angles and speeds that optical equipment struggled to track. Before Japanese gunners could fire, Gamble launched 2 Mark 8 torpedoes from PT-37's tubes. The black powder launching charges ignited with characteristic flashes, potentially giving away his position, but that was irrelevant now. The torpedoes dropped into the water, their motors engaged, and they began their run toward the destroyer column at 28 knots. Gamble didn't wait to observe results. He slammed throttles forward and PT-37 leaped ahead, accelerating through 35, 38, 40 knots. Behind him, PT-40 and PT-48 followed the same attack profile: close fast, launch torpedoes, run faster. Japanese searchlights snapped on, brilliant beams stabbing across the water, seeking the small, fast targets. 5-inch shells began walking across the sea, erupting in columns of white water where PT boats had been seconds earlier. But the PT boats were no longer where the shells landed. At 41 knots, they were somewhere else entirely, racing into darkness beyond the searchlight beams, their wakes phosphorescent trails marking courses already abandoned. The Japanese gunners adjusted fire, tracking the wakes, firing at where the boats should be. And missing. Because 41 knots was faster than their fire control solutions assumed, faster than their doctrine accounted for, faster than any small torpedo boat had any right to be. The first torpedo struck Teruzuki near the stern at 02:12 hours. The explosion was catastrophic, over 400 pounds of TNT, detonating against the destroyer's hull, flooding compartments, damaging steering gear. Tanaka, on Teruzuki's bridge, was thrown to the deck by the impact. His flagship, the newest and most powerful destroyer in the formation, was suddenly crippled, unable to maneuver, losing way. A second torpedo hit moments later, and flames erupted from Teruzuki's aft section as fuel oil ignited. The other Japanese destroyers maneuvered to assist their stricken flagship, breaking formation, presenting targets to the other PT boats, still making attack runs. More torpedoes entered the water. More 5-inch guns flashed in the darkness. The organized resupply run had become chaos destroyers, maneuvering wildly. Searchlights sweeping apparently random patterns, gunfire filling the night with thunder and tracers. And somewhere in that chaos, racing between searchlight beams at speeds that made them nearly impossible to hit, American PT boats continued attacking. Not because they were invulnerable, they were wooden boats that would disintegrate under sustained fire. Not because their torpedoes were reliable, Mark 8s were proving as temperamental as ever, but because they were fast enough to attack and survive, fast enough to close with enemy destroyers, launch weapons, and escape before overwhelming firepower could destroy them. The Japanese crews, trained and confident and equipped with excellent ships, suddenly faced an opponent their doctrine hadn't adequately prepared them for. These weren't the torpedo boats of previous wars, wooden craft that could be run down and destroyed by superior speed and firepower. These were 41-knot ghosts that appeared from darkness, struck, and vanished faster than gunnery solutions could track. Teruzuki's damage was terminal. Fire reached the aft magazines, and the destroyer erupted in a massive explosion that lit the entire sound. Captain Tsuneo Orita ordered the Kingston valves opened, scuttling the ship before she could capsize. Nearby destroyers Arashi and Naganami rescued survivors, 196 men from water, already claiming the rest. By 0440 hours, Teruzuki was gone, taking with her the confidence that small torpedo boats were mere nuisances. She was, according to post-war analysis, the single largest warship sunk by any PT boat during the entire war. Not bad for plywood and 41 knots. Admiral Tanaka, fished from the water and transferred to another destroyer, cancelled the resupply mission. He turned his remaining destroyers north, back toward the Shortland Islands, the cargo and troops still aboard. The Tokyo Express had been derailed, not by American cruisers or destroyers, which Tanaka knew how to fight, not by aircraft, which couldn't operate at night, but by wooden boats moving faster than his forces could effectively engage. The morning of December 12, 1942, brought American reconnaissance aircraft over Iron Bottom Sound. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. They photographed oil slicks, debris fields, and the absence of Japanese destroyers at Guadalcanal. Radio intelligence confirmed what the PT boat crews already knew. Tanaka had turned back. The resupply mission had failed. At Tulagi, Lieutenant Commander Montgomery's after-action reports documented the night's engagement with clinical precision. 15 PT boats deployed. Multiple torpedo attacks executed. The mathematics were remarkable not because PT boats had suddenly become superweapons, but because they'd accomplished their mission while surviving contact with forces that should have annihilated them. The key variable in that survival equation was speed, not the theoretical speed written in procurement contracts, but the actual, demonstrated, repeatable ability to accelerate past 40 knots and maintain that speed long enough to escape Japanese gunfire. The Packard engines, burning fuel at rates that made Navy accountants wince, delivered the horsepower that translated directly into continued existence for PT boat crews. You couldn't armor an 80-foot wooden boat against 5-inch shells, but you could make it fast enough that 5-inch shells arrived at empty water. Japanese naval intelligence began revising their assessments of American PT boats after Teruzuki's loss. The small craft were no longer dismissed as ineffective nuisances. They were redesignated as devil boats in Japanese communications, Akuma no Boto, or sometimes green dragons, reflecting both their painted camouflage and their ability to strike from darkness. This wasn't respect, exactly. Japanese destroyer crews still considered their ships superior in every measure except one. But that one exception, speed, was proving tactically significant. The engagement off Guadalcanal on December 11th-12th demonstrated a principle that would shape PT boat operations throughout the Solomon Islands campaign. Speed enabled aggression against superior forces. Traditional naval doctrine held that small craft should avoid engagement with capital ships. PT boats violated that doctrine routinely, not through recklessness but through mathematical calculation. If you could close to torpedo range at 41 knots, launch weapons, and escape at 41 knots, you could attack destroyers and survive. Sometimes. If your engines didn't fail, if your torpedoes didn't malfunction, if Japanese gunfire didn't find you during the critical moments when you were committed to attack runs and couldn't maneuver evasively, the American Navy, reviewing PT boat performance in the Solomons, confronted uncomfortable truths about their primary anti-ship weapon, the Mark 8 torpedo. The weapon was slow, unreliable, and often ineffective. PT boats fired hundreds of Mark 8s during the Guadalcanal campaign. Most missed. Many of those that hit failed to detonate. The magnetic detonator designed to explode the torpedo beneath a ship's keel malfunctioned so regularly that crews began to distrust it completely. Contact detonators sometimes worked, sometimes didn't. Depth settings were erratic, and at 28 knots, the torpedo itself was slower than many of the destroyers it was supposed to hit. But the boats carrying those problematic torpedoes were fast, maneuverable, and critically available in numbers. By December 1942, 3 PT boat squadrons operated in the Solomons, Squadrons 2, 3, and 6. More boats arrived monthly. Production at Elko and Higgins facilities was accelerating. Each squadron added offensive capability to the American campaign against Japanese supply lines. Individually, PT boats were vulnerable. Collectively, they created a blockade that Japanese destroyers had to navigate while also avoiding American aircraft, submarines, and surface forces. The tactical evolution happened quickly. PT boat commanders learned to operate in coordinated groups rather than individually. 3 to 5 boats working together could saturate a target area with torpedoes while providing mutual fire support. Radio communications, primitive and often unreliable, allowed boats to coordinate attacks in real time. Radar, when it worked, provided early warning of approaching enemy forces. And always, speed provided the margin of survival. Attack fast, withdraw fast, live to attack again. Japanese destroyer commanders adapted their tactics in response. Searchlights became standard for night operations. Illuminate the target, destroy it with gunfire before it could launch torpedoes. Lookout doctrine emphasized wake detection rather than hull spotting, because phosphorescent wakes were often more visible than the boats creating them. Destroyer formations spread out to provide mutual fire support and make massed torpedo attacks more difficult. And Japanese captains became more cautious about committing their ships to waters where PT boats operated. That caution was precisely what the American campaign needed. Every Japanese destroyer that slowed down or altered course because of PT boat threats was a destroyer that delivered supplies late or not at all. Every resupply run that got cancelled because the risks seemed too high was another night that Japanese forces on Guadalcanal went without reinforcement. The strategic impact of PT boats wasn't measured primarily in ships sunk, though Teruzuki represented a significant kill, but in missions disrupted and Japanese operational tempo degraded. The human cost of PT boat operations accumulated steadily. These wooden boats carried no armor. Direct hits from destroyer gunfire meant instant disintegration. Near misses could still be fatal. Blast effects from 5-inch shells exploding in water alongside a PT boat could rupture hull planking and flood compartments. Fire was the nightmare scenario. 3,000 gallons of aviation fuel, stored in tanks throughout the boat, could transform a PT into an inferno within seconds of ignition. Crews knew they sailed in floating bombs, yet they continued sailing, night after night, into waters patrolled by enemy destroyers. The crews were young average age in early 20s and mostly volunteers. They came from every part of America, brought together by the lottery of wartime assignments. Some had sailing experience, many didn't. All of them learned to live with the peculiar combination of boredom and terror that characterized PT boat service. Long hours of patrol through empty darkness, interrupted by brief moments of combat so intense that survival felt more like luck than skill. The boats themselves required constant maintenance. Wooden hulls leaked, engines, pushed to maximum output regularly, needed frequent servicing. Electrical systems corroded in salt air. Weapons required cleaning and calibration. PT boat bases became around-the-clock maintenance facilities, with crews working through daylight hours to prepare boats for night operations. The tempo was exhausting, but it was sustainable because the boats kept running, kept fighting, kept surviving encounters with forces that should have destroyed them. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By January 1943, Japanese forces on Guadalcanal were in critical supply shortage. American air superiority during daylight hours had forced the Japanese to rely entirely on night destroyer runs, the Tokyo Express, for resupply. But now, those night runs faced American PT boats operating from multiple bases, coordinated by improving radio networks, guided by increasingly effective radar. The Japanese Navy could still deliver supplies, but the cost in time, fuel, and risk was rising. Admiral Tanaka, still recovering from Teruzuki's loss, continued running the Tokyo Express through February. But each run required more destroyers for escort, more complicated routing to avoid PT boat patrol areas, more acceptance of risk that had seemed minimal months earlier. The fundamental tactical problem hadn't changed. Japanese destroyers were larger, better armed, and more survivable than PT boats in any direct engagement. But they couldn't catch PT boats that didn't want to be caught. And that speed differential, that simple fact that 41 knots was faster than 34 knots, meant PT boats could choose when to fight and when to run. The initiative, that most valuable of tactical advantages, belonged to the smaller force. This reversal of traditional naval dynamics frustrated Japanese destroyer commanders trained to believe that superior tonnage and firepower determined outcomes. The doctrine that had served the Imperial Japanese Navy well in battles against comparable opponents, American or British destroyers and cruisers, proved inadequate against wooden boats that refused to engage on conventional terms. You couldn't sink what you couldn't hit, and you couldn't hit what you couldn't catch. American propaganda, always alert to stories that boosted morale, seized on PT boats as symbols of American ingenuity triumphing over enemy power. Magazine articles described daring night raids. Newsreels showed PT boats training in American waters, their speed and armament emphasized. The boats became known as the Mosquito Fleet, small, annoying, and surprisingly dangerous. Later, they'd become even more famous through one particular incident involving a young lieutenant named John Kennedy and a destroyer named Amagiri. But in early 1943, before PT-109 became part of American presidential mythology, PT boats were simply one element in the grinding campaign for Guadalcanal. The campaign reached its conclusion in February 1943, when Japanese forces evacuated Guadalcanal under cover of darkness. The evacuation itself demonstrated Japanese Navy skill. They extracted over 10,000 troops using destroyer runs, similar to the supply missions they'd conducted for months. But the evacuation was also an admission of strategic failure. American forces had secured Guadalcanal. The southern Solomon Islands were now American-controlled, and the Japanese perimeter was contracting. PT boats had played their part in that contraction. Not the decisive part that belonged to Marines who'd fought for every yard of jungle, and to air forces that had achieved daylight superiority, and to cruisers and destroyers that had contested Iron Bottom Sound in brutal surface actions. But PT boats had contributed to the cumulative pressure that made Japanese operations in the Solomons increasingly untenable. They'd disrupted supply runs, sunk at least one major destroyer, and forced Japanese commanders to route around them or reinforce against them. And they'd done this while suffering relatively modest losses themselves, a testament to the survivability that speed provided. The lessons learned in the Solomons influenced PT boat development and deployment throughout the Pacific War. Boats in later production runs incorporated improvements based on combat experience. Armament increased. 40mm Bofors guns replaced or supplemented smaller weapons, providing better firepower against the armored barges that Japanese forces increasingly used for supply. Radar improved, giving PT boats better ability to detect targets and avoid surprises. Communications equipment became more reliable, and engines continued delivering the horsepower that made 41 knots possible. But that speed came with costs beyond fuel consumption. The Packard engines required skilled maintenance. Parts wore out under the stress of combat operations. Replacement engines had to be shipped across the Pacific. PT boat tenders, specialized support ships, became mobile maintenance facilities, following squadrons from base to base, keeping boats operational. The logistics of supporting PT boat operations were complex and resource-intensive. Yet the Navy continued the investment because the boats delivered tactical results. One significant operational limitation emerged clearly. PT boats were ineffective against heavily armored targets. Their torpedoes, even when they hit, struggled to damage large warships with heavy armor belts. This wasn't a flaw in PT boat design. They were never intended to attack battleships or heavy cruisers, but it did define their operational niche. PT boats hunted destroyers, transports, supply ships, and barges. Against those targets, particularly destroyers, they proved surprisingly effective when properly employed. The Japanese response to PT boat tactics continued evolving. By mid-1943, Japanese destroyer runs to forward bases increasingly occurred during daylight hours under air cover, accepting the risk of American air attack rather than facing PT boats at night. When night operations remained necessary, Japanese destroyers operated in larger groups with dedicated anti-PT boat screening formations. Seaplanes began dropping flares to illuminate PT boat operating areas, removing the darkness that PT boats relied on for survival. And Japanese gunfire became more sophisticated, with destroyers firing patterns of shells to bracket areas where PT boats might be, rather than aiming at specific boats. These countermeasures improved Japanese survivability but didn't eliminate the PT boat threat. Even illuminated by flares, even under concentrated fire, PT boats at 41 knots remained difficult targets. The speed that American designers had built into their specifications, the 40-knot requirement that had seemed arbitrary during procurement debates, proved to be the critical factor separating PT boats from earlier torpedo boat designs. Previous generations of torpedo boats had been fast for their era, but not fast enough to reliably escape destroyer gunfire. PT boats, pushed by Packard engines burning fuel at rates that seemed wasteful, achieved speeds that provided genuine tactical advantage. The psychological impact on Japanese crews shouldn't be underestimated. Destroyer sailors, confident in their ships and training, found themselves vulnerable to attacks by boats they'd initially dismissed. The knowledge that small, fast craft could appear from darkness, launch torpedoes, and disappear before effective counterfire created persistent tension during night operations. Japanese destroyer crews remained professional and effective. Their performance throughout the Pacific War demonstrated remarkable skill and courage, but they learned to respect the devil boats. That respect translated into caution, and caution translated into operational constraints that benefited American strategy. By the time American forces moved north through the Solomons toward Bougainville and Rabaul, PT boats had become integrated components of naval operations rather than experimental weapons of uncertain value. Squadrons deployed to forward bases as American forces advanced. Their primary mission interdicting Japanese supply lines remained constant, but their secondary missions expanded, rescuing downed pilots, inserting coast watchers and intelligence operatives, harassing shore installations, and providing advance warning of Japanese naval movements. The versatility of the platform, combined with its speed and relatively modest cost, made PT boats valuable beyond their original torpedo attack role. The engagement between PT boats and Japanese destroyers represented more than tactical innovation. It demonstrated how specific technical advantages, in this case, speed, could offset broader material disadvantages. PT boats were wooden, unarmored, and carried unreliable torpedoes. Japanese destroyers were steel-hulled, well-armed, and crewed by some of the most skilled sailors in any navy. Yet PT boats could engage those destroyers and survive because they were faster, not slightly faster, significantly faster, fast enough that the speed differential changed fundamental tactical calculations. The 41-knot specification, written into PT boat requirements by Navy planners who probably never imagined the boats attacking destroyers at night in the Solomons, became the defining characteristic that made such attacks feasible. Every knot of speed translated directly into survival margin. At 35 knots, PT boats would have been catchable by Japanese destroyers. At 40 knots, they were barely faster. But at 41 knots, sustained over the critical minutes of attack and withdrawal, they were just fast enough to attack and escape. That narrow margin, those few extra knots of speed, represented the difference between theoretical capability and practical effectiveness. Japanese destroyer commanders, analyzing their encounters with PT boats, understood the problem, but lacked easy solutions. You couldn't make a 2,000-ton destroyer faster without fundamental redesign. You couldn't predict where PT boats would attack. Their small size and mobility meant they could operate from hidden bases and appear anywhere in their operational radius. You couldn't ignore them. A single hit from a Mark 8 torpedo, despite its unreliability, could cripple or sink a destroyer. And you couldn't reliably destroy them because they simply outran your gunfire. This tactical dilemma shaped Japanese destroyer operations in the Solomons throughout 1943. The Tokyo Express continued running. Japanese forces needed supplies, and destroyers remained the fastest way to deliver them. But each run required more planning, more escorts, more acceptance of risk, and each run faced the possibility of encountering devil boats racing out of darkness at speeds that made them nearly impossible to hit. The cumulative effect was operational degradation. Japanese forces received less supply than they needed, delivered less reliably than planned, at higher cost in fuel and risk than sustainable. The American PT boat program, meanwhile, expanded rapidly. By mid-1943, PT boat production exceeded squadron requirements. New squadrons formed monthly. Training facilities in the United States produced crews faster than boats became available. The industrial capacity that allowed America to build hundreds of PT boats, each requiring significant quantities of mahogany, aircraft engines, and specialized equipment, was the same capacity that produced thousands of aircraft, hundreds of destroyers, and dozens of carriers. But PT boats represented a particularly efficient use of that capacity, relatively cheap to build, quick to produce, and capable of engaging enemy forces far larger than themselves. The crews manning those boats came from American small towns, cities, farms, and factories. They received training in boat handling, gunnery, torpedo operations, and basic seamanship. Then they shipped out to the Pacific, where they learned the real lessons: how to navigate by stars when radar failed, how to distinguish destroyer silhouettes in darkness, how to judge the exact moment when throttles should slam forward for escape, how to survive when survival seemed improbable. These were practical skills, learned through experience, often at the cost of boats and men that didn't survive the learning process. The mathematics of PT boat operations remained brutal throughout the war. For every successful attack, like the sinking of Teruzuki, there were dozens of patrols where torpedoes missed or malfunctioned. For every escape at 41 knots, there were boats that took hits and exploded in fuel-fed infernos. The wooden construction that made PT boats light and fast also made them vulnerable. A single 5-inch shell could tear through mahogany planking and detonate inside the boat, killing crew and destroying systems. The same fuel capacity that enabled 12-hour patrols meant boats carried enough gasoline to turn them into floating bombs. Yet the program continued, expanded, and achieved results because speed, that 41-knot design specification, provided just enough advantage to make the risks acceptable. Not safe, never safe, but acceptable within the context of naval warfare, where all choices involved risk, and the question was always whether the potential gain justified the certain cost. PT boats, attacking Japanese destroyers at night in the Solomons, achieved gains in ships sunk, supplies interdicted, and operations disrupted that justified their costs in resources, fuel, and lives. The legacy of those engagements extended beyond the immediate tactical results. PT boats demonstrated that small, fast, well-handled craft could challenge larger opponents when speed enabled hit-and-run tactics. This principle influenced post-war development of fast attack craft in multiple navies. The idea that speed could substitute for armor in certain tactical situations became embedded in naval thinking, and the specific lessons of the Solomons campaign, how to coordinate multiple small boats, how to use radar and radio for tactical advantage, how to attack and withdraw before superior forces could respond, shaped doctrine for decades. The Japanese Navy, for its part, learned complementary lessons. Speed alone didn't guarantee safety. Organization, training, and doctrine mattered enormously. But when opponents possessed both speed and competent employment of that speed, traditional advantages in tonnage and firepower became less decisive. This was troubling doctrine for a navy that had invested heavily in powerful destroyers designed for night surface action. The discovery that those destroyers could be effectively engaged by plywood boats powered by aircraft engines represented a tactical surprise that required operational adaptation. The story of PT boats and Japanese destroyers in the Solomon Islands ultimately transcended individual engagements. It became a case study in how specific technical advantages could reshape tactical possibilities. The Japanese laughed initially at American plywood boats claiming 41-knot speed. Such craft seemed absurd compared to steel destroyers displacing thousands of tons. But laughter ended when those plywood boats actually delivered on their speed specifications, attacked with impunity, and escaped before overwhelming firepower could destroy them. The irony was deliberate in Japanese naval circles. By late 1943, intelligence reports no longer dismissed PT boats as negligible threats. They were catalogued, tracked, and planned against. Destroyer captains briefed their crews on devil boat tactics. Lookouts, trained specifically to spot phosphorescent wakes in darkness. Gunnery officers developed firing patterns designed to bracket areas rather than target specific boats. All of this represented recognition, grudging professional recognition that speed had changed the tactical equation. American PT boat crews, reading translated Japanese documents after the war, discovered they'd been nicknamed Devil Boats and Green Dragons. The names carried a certain respect, the kind professional warriors accord worthy opponents. Japanese destroyer sailors hadn't feared PT boats in the way they feared American battleships or carrier aircraft, but they'd learned to take PT boats seriously, which was perhaps more significant. Fear could be overcome through courage, but serious tactical threats required serious responses, which consumed time, planning, and resources. The mathematical reality remained simple. 41 knots was faster than 34 knots. Everything else, tactics, training, weapon systems, built on that foundation. Without the speed differential, PT boat attacks against destroyers would have been suicidal gestures rather than viable operations. With it, they became calculated risks that sometimes succeeded and sometimes failed, but always remained within the bounds of acceptable naval tactics. The Packard engines that delivered that speed consumed fuel at rates that seemed wasteful to peacetime sensibilities. 500 gallons per hour at maximum power, enough gasoline to drive an automobile from coast to coast, burned through in 60 minutes of combat operations. But wartime calculations measured value differently. If 500 gallons of fuel enabled a PT boat to sink or damage a destroyer worth millions in construction costs and months of shipyard time, the fuel was efficiently spent. If that same fuel enabled the boat to escape destruction and remain operational for future missions, it was essential expenditure. The torpedo problem, never fully resolved during the war. Mark 8 torpedoes remained slow and unreliable through 1943. Later Marks improved performance, but never achieved the reliability that American submariners and PT boat crews desired. Yet PT boats continued using torpedoes as primary weapons, because even unreliable torpedoes occasionally hit, and hits occasionally sank destroyers. Terazuki demonstrated that possibility. Other engagements reinforced it. The combination of speed for delivery and torpedoes for destruction, despite individual component limitations, produced tactically significant results. Japanese forces evacuated Guadalcanal in February 1943, ending the 6-month campaign for the island. PT boats hadn't won that campaign. Marines, aircraft, cruisers, destroyers, and the entire American military-industrial complex had won it. But PT boats had contributed their part, disrupting Japanese supply lines during critical periods, sinking vessels that Japanese forces desperately needed, and forcing Japanese commanders to allocate resources to counter threats they'd initially dismissed. The broader Pacific War continued through 1944 and into 1945. PT boats deployed to New Guinea, the Philippines, and throughout the island chains that American forces captured on the road to Japan. Their role evolved more gunboat work against barges, more reconnaissance and rescue missions, fewer direct attacks against major warships. But the boats retained their fundamental characteristic, speed. Whether attacking, evading, or simply transiting between bases, PT boats moved fast because their Packard engines and planing hulls enabled speeds that conventional displacement hulls couldn't match. The men who crewed those boats through 3 years of Pacific combat experienced warfare at its most immediate and personal. They saw enemy destroyers close enough to distinguish individual crew members. They felt their boats shudder when torpedoes launched. They heard 5-inch shells shrieking overhead and watched tracers arc through darkness, and they learned whether their engines would deliver the promised 41 knots when survival depended on it. Most times, the engines delivered. Sometimes they didn't, and boats exploded or sank or disintegrated under enemy fire. By war's end, in August 1945, the American Navy had built over 500 PT boats. Most were scrapped immediately after surrender. The wooden hulls weren't worth maintaining in peacetime, and the operational concept had limited post-war application. But while they served, they demonstrated a principle that outlasted their individual existence. Speed could compensate for vulnerability when properly employed. Small forces could engage large opponents when speed-enabled hit-and-run tactics, and technical specifications that seemed marginal during procurement, like requiring 41 knots instead of 39, could determine tactical effectiveness in actual combat. The Japanese Navy, rebuilding after the war within severe treaty limitations, incorporated lessons from their PT boat encounters into new designs. Speed received renewed emphasis. The idea that small, fast craft posed serious threats influenced defensive doctrines, and the recognition that American ingenuity could produce effective weapons from unlikely materials, plywood, aircraft engines, and young crews shaped Japanese understanding of American capabilities more broadly. The story began with skepticism. Japanese destroyer officers, confident in their ships and training, initially dismissed American PT boats as ineffective novelties. The story ended with recognition. Those same officers, survivors of night engagements in the Solomons, understood that plywood boats moving at 41 knots were legitimate tactical threats requiring serious countermeasures. Between skepticism and recognition lay the combat record. Teruzuki sunk, supply runs disrupted, and the cumulative realization that speed specifications written in procurement documents translated into operational capabilities that changed naval warfare. The PT boats proved their speed wasn't exaggeration. 41 knots was real, achievable, and tactically decisive. The Japanese learned this lesson through experience, the hardest teacher but the most convincing. They'd laughed at American claims about plywood speedboats. Then the torpedoes arrived, launched from boats moving faster than destroyers could chase. The laughter stopped, the war continued, and the devil boats raced through darkness at speeds that transformed them from jokes into threats that shaped the Pacific naval campaign. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.